Hi, I'm Scott Vorthman, the author of vZome. I'd like to talk to you today about uniform and regular polyhedra and how you can generate models like this one very quickly and easily using some new features in vZome. This video will be the first in a three-part series, and we'll talk about the other two parts toward the end. So the first new feature I want to show you is something called Symmetry starters. You can find them in the Help menu. There's several kinds. In this video, we'll focus just on the icosahedral dodecahedral starter and what you can build with it. When we click on it, we're going to get a new untitled document, but it's not empty as usual with just a ball. We have this sort of weird, long, skinny tetrahedral shape, kind of a cavity, and some colored balls and struts inside of it. Turn off outlines. So with this, we can very quickly and easily generate a number of uniform and regular polyhedra that have icosahedral symmetry. So let's start with the yellow ball. So I simply select it, then I apply my icosahedral symmetry tool, which generates a number of other vertices. And now I'm going to show you the second new tool, which is the 3D convex hull tool. So this comes to us thanks to my collaborator David Hall, along with the 2D convex hull. It's a very nice tool. It simply builds the smallest structure that contains inside it all of the selection that we had. So in this case, it's a regular dodecahedron. This is a regular polyhedron because it has regular polygon sides, pentagons in this case, and just one type of edge and one type of vertex. So you probably already knew how to make a dodecahedron with vZome. Maybe you know how to make this one too. If we use the red ball, we're going to produce our old friend, the dual of the dodecahedron, which is the icosahedron. Again, this is a regular polyhedron. It has equilateral triangle sides, which are of course regular. So no big surprise there. If we go to the third corner of our funny little tetrahedron, the blue ball, and we apply this one, we no longer get a regular polyhedron because now we have two kinds of faces, triangles and pentagons. But since they're both regular and we still only have one kind of vertex, all vertices are symmetrical, then this is called a uniform polyhedron. This one is called the icosahedrodecahedron. All right, so much for the corners. We have a number of other balls here. There's really only 7 possibilities in terms of, we have 3 balls that lie each on 2 mirrors, on two of the side panels. We have 3 balls that lie only on 1 mirror. And then we have 1 ball that lies in the middle, not on any mirrors at all. Now I've also left in the navy ball here, and I'll show you why I have that a little bit later. So let's start with lavender and apply our procedure and see what we get. Again, we have a uniform polyhedron, but now we have 3 kinds of regular faces: squares, equilateral triangles, and pentagons. Okay, so this is the rhombicosahedrodecahedron. I'm not going to show you the sulfur and the rose. I'll leave those as an exercise for you. But let's take a look and see what we get with the navy ball. Now this is similar to lavender. It still lies only in the blue plane. And if we do our convex hull, we still get 3 kinds of faces, but now our squares have turned into golden rectangles. And of course, this is our old friend, the vZome ball shape. So this is not a uniform polyhedron, but I wanted to show it just to emphasize that the starter for icosahedral symmetry can be used to build any object that has icosahedral symmetry. It doesn't have to be only used for these particular spots, these particular uniform polyhedra. So finally, let's talk a little bit and look at the spruce ball and what we get. Now this one's a little bit different. If I simply naively do the same thing that I have been doing, I'm going to get something a little bit unexpected. There are no blue struts. This object has no mirror symmetries at all. It does have, however, all of the rotation symmetries of an icosahedron. And there's a very particular reason it does. That's because that's all I get when I apply my icosahedral symmetry tool. it didn't matter as long as we were lying in these mirror planes, these edges of our triangle. But as soon as we're lying out in the middle, it does matter. So there's a very simple solution. The other part of this starter that comes with it is 3 built-in tools: a red mirror, a yellow mirror, and a blue mirror, obviously corresponding to the edges, the faces on our tetrahedron. So I can just use any of the 3. I'll use the yellow mirror, and now I have a single ball and its reflection. So once I have a single reflection, when I apply all of the icosahedral symmetries, all the rotation symmetries, I will also get all of the reflection symmetries. And so now we have our great rhombicosadodecahedron, the largest member of the uniform polyhedra that have icosahedral symmetry. Now there's one more thing that I want to show you that you probably want to be able to do once you've made your lovely polyhedra or any other object. You probably want to get rid of all this scaffolding here. So I've included a bookmark called Starter Scaffolding. It's a selection bookmark. So if you simply select it and delete, you'll get rid of all the scaffolding. Now, unfortunately, you'll also get rid of the ball you used. So let's undo that and simply deselect, and happily it comes back white, and then delete again. And there you have it. So in the next video, part 2 of the series, we'll look at the other symmetry starters here and the polyhedra you can build with them. And in the third video, we will look at some of the geometry and mathematics that's happening that we're applying as we use these starters. Thanks for watching.